Okay, this is Unit 1, Lesson 1 of logarithmic and exponential functions. So we're going to talk about our exponent laws, reviewing exponent laws. There are 5 main exponent laws that correspond to the log laws. So our first 5 are on the left-hand side, the rest are on the right-hand side. So the first one we see on the left, we have the bases that are identical. So when the bases are identical, what are you noticing they're doing to the exponents? They are adding them. So I could have 4 squared times 4 cubed to give me 4 to the 5th power. Okay, we're just going to add exponents. That's when you're multiplying the base must be the same. The exact opposite of that is when they're dividing. A fraction line means divide, so if you're dividing, you're going to subtract the exponents. So if I've got 5 exponent 11 over 5 exponent 9, I'm going to get 5 squared. Okay? The next one you see brackets. So there's an exponent on the outside of brackets. This guy's going to have to multiply to the exponent on the inside brackets. When they're variables, that's what sitting side by side means, is they're multiplying. So if I've got 2 squared, all cubed, that's going to give me 2 exponent 6. The next law we have is the hidden 1 law. Basically, it's saying any variable or any digit always has an exponent, and it's always a hidden number 1. So I could have the number 7, it's got a hidden 1 on it. I could have a number 11, it also has a hidden 1. Everything has a hidden 1, okay, unless you see a different exponent. Then we get into the 0 property, the 0 law. So anything with the exponent of 0 always gives us an answer of 1. And the reason is because of this. So if we take a look at a pattern, if I start with 3 cubed is 27. 3 squared is 9. How do I get from 27 to 9? Divide by what number? 3. It's the base number. Let's try again. 3 exponent 1. If I take 9 and divide by 3, well, that's just going to give me 3. Okay, and 3 exponent 1 just says, oh yeah, I got 1 3 there, guys. And next, 3 exponent 0. Well, I'm going to divide by 3 again. What's 3 divided by 3? 1. And it'll happen every time. That's why it works. Okay? So that's known as the pattern for the power of 0. Then we talk about, on the right-hand side, we talk about other exponent laws. So now we've got different bases in brackets. That's why they're indicated with different variables. So whenever you've got different bases in brackets, it's identical to our power base law, which states it goes to every base. So there's hidden 1s on the A and the B, and the n distributed into those 1s and multiplied to those 1s is what happened. That removes your brackets. So right here, I could have 2w all exponent 4. Well, the 2 and the w each have a hidden 1 on them. So that 4 is going to multiply to both those 1s. So in order to remove the brackets, my answer is now going to be 2 exponent 4, w exponent 4. Okay? Now, if it asks us to simplify or evaluate, you would solve the digit. You'd say 2 exponent 4, 16. So now your answer would be 16 w exponent 4. Okay? The identical thing happens on the other side when we look at the opposite feature. Here we were multiplying side by side. Right here on the right, on the bottom of that one, we have dividing. Now this is different bases again, 2 different letters. That means different bases. So again, they both have hidden 1s. The n is going to distribute to each of those 1s. So an example could be 5 squared on top of 4 cubed, all to the 4th power. And then to remove the brackets there, let's just get rid of this for now. So this is going to give us 5 exponent 8 on top of 4 exponent 12. Okay? You're just going to multiply the exponents into the bracket to every exponent. You're not allowed to forget any of them. Our last 2 laws just deal with flipping and putting numbers in opposite places. So, we take a look at our second last law here, the guy with the negative. This basically states that any negative exponent can be changed to a positive exponent if you put it in the opposite place in a fraction. So, for example, any number or variable can be put over 1 to create a fraction. Right now I've got a negative on the top, a negative exponent on the top. If I want that guy to become positive, he's going to go to the opposite place in the fraction. Right now he's on top, he would go to the bottom to become positive. So that's why we ended up with m positive on the bottom. Okay? Now note, this could also work like this. If I've got, let's say, in brackets, 5 to the negative 4 over 6 to the negative 3. And I want you to simplify that into positive. Well, if you're going to simplify it into positive, all you're going to do is trade them places. So the 4 is negative, so that means this whole expression, that whole power, is going to change to the bottom. And then he's going to become positive 4 on the bottom. Remember, the base does not carry the negatives, okay? The negative only applies to the exponent in this case. The one on the bottom who's negative, he's going to go to the top to become positive. So he's going to become 6 exponent 3. Okay, positive 3. So they're in opposite sides or opposite places of your fraction. One on top, one on the bottom. So literally you just flipped it off. Now, another variation of that question could be something that looks like this. So I'll put it up over here so we can see it. So you could have something where you've got positive exponents on the inside and you might have a negative exponent on the outside. So you could have 4 cubed over 2 to the 5th power all to the negative 6. If you've got a situation like that where they're both positive inside and the negatives outside, you flip the inside and that'll change your 6 to your positive. Okay, that's one strategy. That's a quick trick. The way it actually works is this. You would multiply the negative in, that gets rid of brackets, and then they'd be negative on top, negative on the bottom. You can flip them in places just like this guy. But the quick trick is, if the negative's on the outside, just flip the inside. That's going to make the outside guy go positive. Okay? So really, I could rewrite it as 2 to the 5th over 4 cubed. And then it would all now be to the positive 6. And then you would distribute the fraction, or the exponent. So it would be 2 exponent 30 on top of 4 exponent 18. Okay? And you would have got that if you did it the long way. You would have got that just by multiplying this guy in and then flipping him at the end. Okay? So 2 ways to do the question, but you both get the same answer. Alright, our very last one is taking a fraction exponent and changing it into a radical. So, the rule is this. The bottom number, the denominator, he's the one that's going to slide over into the index part, the check mark part of your radical. Okay? The top one then will just slide down and stay on top as an exponent. Okay? So, let's take a look at an example. So, this guy right here. So if I've got, let's say, 6 to the 2/3, and I want to write that as a radical. The 3 is going to slide over to an index, and the 2 is going to stay on top as a fraction. So it's going to look like cube root of 6 squared. Okay, that's how that would work. That's where the numbers flip-flop to. So cube root of 6 squared. Okay. All right, let's move on to the next one. So there's a few practice questions here. I want you to see how far you can get. I'll give you about 5 minutes to go through as many of these as you can get, and then we're going to go through them together, okay? The more challenging questions are on the bottom of the page. Okay, push pause now and play when you're ready. Okay, we're going to check these guys out. So here, the x is a time sign. So you're going to get 3 exponent 6. And how big is 3 exponent 6? 729. Okay? Over here, we're going to multiply the brackets. So we're going to get 2 exponent 6, which is going to give us 64, Over here, we're going to get negative 2 in brackets, because that's our base. And 5 subtract 2 is what we're doing. We're going to get a 3. And we can solve this. That's going to give us negative 8. Okay? So you just type in your calculator, negative 2 exponent 3. Over here, it is side by side. Side by side means multiplying. So you're just going to add the exponents, 4 and 3, to get 8 exponent 7. Don't forget there's a hidden 1 on this x. So you're going to have x exponent 7. All these b's, those x's are time signs here, you're just going to take 7 plus 0 plus 4 to get b11. Sounds like a vitamin. The next one, you're going to times 4 and 3 to get a exponent 12. How's everybody doing so far? Pretty good? Excellent. Let's move this up. Think goes too fast? Okay. The next one, they're both negatives, so there's nothing else you can do there. There's no coefficients, there's no brackets. The only thing you can do is flip it. So we're going to flip this guy upside down. We're going to have h, the 5 now becomes positive, the j now becomes positive 8. Okay. This guy, it's dividing, subtract exponents. So y exponent 6. This little guy here has hidden 1s on the s and the t. So that 6 is going to multiply in the brackets to both of those exponents. So you're going to get s exponent 6, t exponent 6. All of these have hidden 1s. There's 2 ways to do this question. You could write this out 4 times, okay, so that you would see 4 negative 3s. Or, because it is a bracket question, you can multiply it in. Now, when you do that, because there's a negative in brackets, the negative stays in brackets to take the exponent. Okay? It has to. The next, p to the 4, q to the 4, and then we solve the coefficient. And that's going to become positive 81, p exponent 4, q exponent 4. Okay? Any questions so far? Okay, last page here for this lesson. Let's take a look at what are we going to do is bedmass. This x in brackets, this one right here is just a time sign. So what we're going to try and do is we need to simplify the brackets first, and then we apply the exponent in after. So we need to multiply coefficients. So we're going to get 12 x6 y3 all on top of 6x exponent 5. All still exponent 4. So I multiply my coefficients up top, that's all I've done. At this step, hopefully you can see a couple things you can reduce. What are you able to do at this point? Yeah, you can subtract x's. So I'm going to take a look at my x's here. I've got 6, and I can subtract 5 of them. How many are left? 1 of them. Now, I can also take my coefficients, and I can divide the coefficients. So when you divide your coefficients, we're going to get 2, x exponent 1, and how many y's do we end up with? 3. Good. Now, this is still in brackets, all exponent 4. All we've done is we have done the bedmass in the brackets and simplified inside. Now the bracket's not even in fraction form anymore. So all we've got to do is put the hidden 1. Where's my hidden 1 missing? On the 2. Perfect. So you draw it in so you don't forget it, and now we're going to multiply that 4 into all 3 of those exponents. And that's what removes your brackets here. So this guy is now going to become 2 exponent 4, x exponent 4, y exponent 12. And there's only one additional thing you can do to this question, and that is solve the coefficient of 2 exponent 4. So it's going to become 16, x exponent 4, y exponent 12. Final answer for the first one. Is there anyone that got that question right? Good job, you guys. Okay, now we're going to take our next one. What we notice is the only thing we can do with this question. We can flip the inside. That'll make the outside guy go positive. Or we can just multiply it in as a negative and then flip it in the end. 2 ways to do the question. It doesn't matter which way. I'm going to flip it inside. So I'm going to get R4 p squared all exponent positive 3 which gives us r to the 12 over p exponent 6. So hopefully you got that. Okay? So you can flip it inside, that's going to make the outside turn positive, or multiply the negative in and then flip. Alright, next one. All we can do with this question is put it in radical form. Okay, that's all we can do with this question. And same with this question. We're going to make it a positive exponent and then put it in radical form. So this guy is a radical. Which part is attached to the exponent? 5 or the x or both? What do you think? Is it the 5 that belongs to the 4 over 7? Or is it the x? Or is it both of them? Only the x. If it was both, they'd be in brackets. Okay? So this guy only belongs to the x. So that means the radical is only going to be on top of the x. So let's get rid of that there. So this guy's going to become 5 times, I'm going to put my root sign now. You know we've got an x under the radical. Which number is in my index? The 7. Good. Down the bottom. And the 4 just stays as an exponent. Okay? So that's all we can do. The 5 will be the coefficient of the radical. Okay? That's all we can do there. The one beside it, we need to flip it. But it's not in a fraction. So how do I flip a number that's not in a fraction? Put it in a fraction. So how do I make it into a fraction? Over 1. Good. All right. Just get rid of this. So, over 1. And now we're going to flip it top bottom. So we're going to get 1 over v to the positive 3 over 5. Now we're going to put the 3 over 5 and the v into a radical. So that's going to be 1 over, here's my root sign, and v's underneath. Okay. Who goes in the index? 3 or the 5? 5, down the bottom. So that means the 3 stays on top as an exponent. Okay? And we're going to go to the left, bottom left there. So if we take a look at the bottom left, we only have 2 variables on the bottom. So that means one of the variables on top doesn't have a buddy to add or subtract with. And that's okay. So we're going to take these 2 x's and we're going to subtract the exponents. We're going to take the y's and we're going to subtract their exponents. And whenever you solve a question, all of your answers would, if it was in a fraction, would go on the top. Even if you get a negative answer, it would initially go on the top. And then we convert it to a proper positive by flipping it. So this guy is going to become x exponent 1, y exponent negative 2, with z still negative 1 beside it. So now we want to get all positive, so we're going to take this guy over 1. Okay, last thing we're doing, the only last thing you can do with this equation here is take the negative exponents and flip them to the bottom. So the following answer, and very final answer, is going to be x over y squared z. Hidden ones on the x, hidden ones on the y. So that's as far as you can go on that question. This next question is a little bit more complicated. It goes with 2 different laws we've got here. So the first law we have is division. Division means we are going to subtract exponents. However, I need to solve on the top of my fraction and solve on the bottom of my fraction. So my top is solved for a number, so I've got x for 1/2. My bottom, I need to solve it for a number. So I've got x exponent 2/3 timesing by, I'm going to change this to a fraction exponent, x to the 1/2. So we're taking a root of x, big exponent 1, get an index of 2. So what's happening? That 2 is sliding under the 1 and creating a fraction. So now, on the bottom here, we've got x 2/3 times x to the 1/2. Well, at this point, we need to add exponents. So, 2 ways to do this question. If you also notice, x to the 1/2 is also on top. So we've got x 2/3 times x to the 1/2 on the bottom. If there is something identical on the top and the bottom, they will cancel out. So this 1, x to the 1/2 is going to cancel out. But we can't forget there's a hidden coefficient of a 1 in front of that example. So that means the top number doesn't just disappear, it now becomes a 1. So the final answer will be 1 over x to the 2/3. The other x canceled and disappeared. So that is your final answer. Last two. These last two, this guy's going to flip into a fraction exponent. So we're going to have 1 over w to 9 over 2. And if we wanted to see how the question originated, we're going to flip them back up top to give us 1 over, flip them up top, so no more 1 on top. That's going to become a w to the negative 9 over 2. So that's our final answer for that question. Now, this next one, this one just wants us to put it into a fraction. There's no fraction exponent, there's no fraction situation. So this one is just a split conversion. So we're going to convert the question into exponent form. The base stays the base, the 2 stays the top exponent, the 3 is going to slide underneath to become the composite. So this concludes lesson 1.0 on review of exponent laws.